In this lesson, we're going to see how to optimize database queries. However, as with any optimization, we need to first profile or analyze our site. So we're going to see a tool that is going to help us get started on that front to see where we are issuing the most queries. To help us with the goal of profiling our website and seeing where we're issuing queries, I've gone ahead and installed the Django Debug Toolbar. Now the Django Debug Toolbar does a whole lot more, but that's what we're going to be using it for. I've taken the liberty, while I was installing the Django Debug Toolbar, of using our environment loader on allowed hosts. This is normally because when you're using Django Debug Toolbar, you want to be able to control the allowed hosts as well as a set of internal IPs for deciding when to show the Django Debug Toolbar. I've deviated from the installation instructions just a little bit, however. The debug toolbar has been added to the installed apps, and you can see we're in the development settings, so I'm simply appending to it. I've had to go ahead and add the debug toolbar middleware into the middleware, and I've added it after a few of the middlewares that have already been specified in our list of middleware. And I've then said that instead of relying on internal IPs or any other method where debug toolbar might decide to show, I've simply said, you know what? I want to decide to show the Django Debug Toolbar in the event this returns true. And what this function does is simply say, oh, I would like to go into the environment and see if there is a Debug Toolbar environment option. If so, let's just return that Boolean. Now, if this doesn't exist, it's instead going to look at the debug option, which in this configuration you can see is default of true. So this allows us to control the two independently. Now, I say independent, but down in config URLs, I've kept this fairly simple. You might want to improve this or change this depending on how often you are going to be setting debug false and then still showing the debug toolbar. I find that I don't end up doing that. I'm usually in debug and then don't want to show the debug toolbar. But if that is not your use case, well, this code will not work for you. That said, I'm just going to leave this here, and all of this does is make sure that in the event that we are in debug mode, the Django Debug Toolbar paths are available for showing that information. I note, as mentioned earlier, that I've taken the liberty of changing allowed hosts. That was set in settings base, so I've removed the setting from production. That means that if you were to redeploy the website as it is right now, you would have to set a new variable in your environment that has this value for Heroku to still serve your website as is. Now let's slide on over. I just want to point you before we actually look at what the effect on our site is, that this is where you can see the Django Debug Toolbar documentation. So there's a whole host of stuff that this allows you to do, different ways of setting it up if you need it to behave slightly differently from the setup I've given. But generally what happens is you're going to come over to the site. You'll see that there's a little panel over here. If you click it, this gives you a whole host of information, and you can see all sorts of stuff. There are two panels that for us we are going to be focused on. The first is on the amount of time. This is always interesting to see what is taking so much time for loading your website. But as the name of this sublesson implies, we are really interested in what is happening in the SQL. Now you can see that for just this one page, we are issuing 9 queries. This is a little bit of a trick. I've actually gone ahead and changed this template to demonstrate one of the major pitfalls in Django. Most people will show up and they look at their views and they say, oh, but my view has only a single query, I'm good to go. A lot of the time, the extra queries are being incurred within the template. So if I slide back over to my terminal and I take a look in this tab, you can see that I've gone ahead and changed the template post list template. And in here, I've created a new section, and I've simply listed out the startup and tags related to our blog post. Now you'll note that unlike in our other templates, I'm not using the with template tag. I've simply called post startups all, both for pluralization and then for the actual listing. Same here to pluralize tags and same here to list through the tags. Now what this means is that for each and every single one of our blog posts, we're actually incurring 4 extra queries, right? That is 4 queries per blog post. And to actually see that, I can slide back over to my browser, click on SQL, and I can see that this is the list of all the blog posts. And then I have right here, I can see that I'm selecting a startup for a specific blog post. And I slide down, and I can see that this is being incurred here on line 23 of the template, where we are simply pluralizing the startup here. Is there an S or not an S? So that's an entire database query for us right now, which is very expensive for a single letter. But if I take a look at the third query, it's the same query for the same blog post, but it happens just 2 lines later, right? We are issuing a whole other database query for exactly the same data as before. And I can slide up. We'll see the same. This is for the tags. But if I come down here, this is again, here we are back for another run at startup for just pluralizing it. But this time, it's for the next blog post. Now we only have 2 blog posts here, which is why we only have 9 queries. But if you were to go and add a whole host of other blog posts, this number would balloon very, very quickly. So our goal is going to be trying to improve this page. And we're going to look at the 2 tools that Django provides us for improving the number of queries we make in the views. Now we could have a few small optimizations, again, by using the with template tag in our template, and we're going to forego that in this example simply so we can focus on these 2 tools. Now speaking of that, I'm going to slide over here to this other tab, which is the Jupyter Notebooks. You can see I've already opened the Jupyter Notebook for this lesson, 402, that I've come over here, and I'm going to take the kernel, and I'm going to restart and clear the output. Now the first tool that I want to focus on is the select related tool. You can see that we're not spending a whole lot of time on it because given our data model, it is not directly applicable to us. Now this is not to say it is not a powerful tool, but we just don't have the right data model. And this is sort of this reinforces, in my opinion, my earlier point, which is that how you optimize your site is going to be heavily dependent on what your site does and what your data models are. So this is not something that is going to be directly applicable to our site, but it is one of the most powerful data optimization techniques or tools provided by Django. So here I'm just going to load all of the links in our database, and then I can take a look at the actual SQL that was used to go and fetch that, right? And you can see that I'm simply getting the information about the news link, nothing else. But if I were to show all of the news links and I wanted to, have a list of all the news links, and then I want to have a link to startups with the name of the startup, I would then have to not only display the information, but for that display, I would have to issue a separate query to get each startup for every news link. Now I can avoid that by saying, oh, I would like you right now to select all of the related startups. So select related is specifically for finding related data for foreign keys, which is why I've selected the news link, right? We don't have any such view. We don't actually need to use this. But so it's specifically in the event that you have one object with a foreign key to another object, and when you're going in that direction. So you cannot use select related from the startup's perspective. If you are trying to preload all of the news links for a set of startups, you cannot use select related because it is a many to, or it is a one-to-many relationship rather than a many-to-one relationship. I think I've got that right. But so the bottom line is that if you are on the object that has the foreign key, you can use select related. If you're using the reverse relationship of a foreign key, you cannot use select related. You'll have to use the next tool that we see. But to sort of finish up on that thought, you can see that this has directly impacted our query, which is not super surprising, right? We are avoiding a set of queries by saying, oh, but at the same time as you get all this data, please use an inner join on the database to go and find the startups that are related to our newslink objects. Now, for handling many-to-many relationships or the reverse of a foreign key relationship, we have the prefetch related. Now this is a bit of an unusual tool, and you can see here that I'm first getting all of our posts, and then I'm saying I'd like all the posts as well, but this time I would like to have all of the startups that are related to this set of blog posts, right? So the list of blog posts, find all the startups related to all of the blog posts in this list of blog posts. And if I go ahead and load that, I then want to make sure that I get all the same blog posts, and this should not be any real surprise. But I should expect that the query, or I might expect that the query is different. But the query is exactly the same, which is, I think, a little bit surprising when I discovered this. You can see that we're simply going and getting the blog post information. What's actually going on is that Django is issuing a completely separate database query for our startups. So this will show us the actual query that we used to go get our blog posts. And then we can see the query that was used after to go and find the startups that were related to the IDs that were loaded in this query. Now that's how it's limiting it down, as it's using the IDs from this query here. Django is then going through the data and making sure that they're related, and that way, if you're using any of the model managers, you're going to go ahead and not issue any further queries because you've already issued that query, you already got it at the same time. How then might that be an optimization, you might ask? Well, the first thing is that you aren't going to be issuing a new query for each and every single object, as we saw in the template. You will only be doing that once. But let's dive deeper into it and take a closer look. So I've gone ahead and reset the queries here, and that means that I expect that there are no connection queries that I get to look at in the list of connection queries. Now I'm going to go ahead and again ask for all the blog posts and all the startups related to those blog posts, and you can see that there is no database, right? Query sets are lazy. This has not been evaluated. It just created a query set. If I want to evaluate the query set, I have to force evaluation by acting on the data. So I turn it into a list, and then we can see that there is a database connection. Now, I'll note that if you're coming from an older version of Django, as I was, or M, I suppose, this has changed a little bit. And this includes not only the SQL, it also tells you how much time it took, which is interesting output. And this is, so I believe previously, this was only providing you with the SQL query. But I'm suddenly second-guessing myself, and I'd like to retract all of those statements. You have no proof that I said any of these things. Moving ever forward, I'm going to go ahead and again reset these queries, and now I'm going to issue a slightly different prefetch related. You can see that I'm asking for the startups that are related to the blog post, and then I'm using a double underscore here and asking for the tags. What I'm doing is I'm saying I would like a list of all of our blog posts. I want the startups that are related to the blog posts, and then I want the tags that are related to the startups, right? These are not the tags that are related to the blog posts. We'll see how to do that later. These are the tags related to the startups which are related to the post. Now, if I go ahead and do that, I have 3 different queries. And you can see that we go ahead and we say for these 2 blog posts, we are going to have these 2 blog posts, find us the related startup. By the look of it, there's only a single ID, so we're only finding one startup and then getting all of the tags related to that single startup. But in the event that there were multiple of these, we would be coming back with all of the tags for all of the startups that were coming back from this query, and we would then have the ability to operate on all of those without issuing any extra queries, which is, I think, quite powerful. Now, you'll notice that I did not specify startups in the last query. I simply specified startups __ tags, and I got the list of startups. So this is, in fact, exactly the same as before, but completely redundant. Now, we can go ahead and we can run this query, and you can see exactly the same output. This is a little bit hard to read. Now, if I wanted to see just the SQL for all of this, I can go ahead and use a list comprehension just to get the SQL. And then I can go ahead and use a little utility here where I'm going to go and get the SQL for all the queries here and try and assert that these are equal. And now I can say, oh yes, is the SQL equal for the post connection, which was our original query here, right? Which is just for startups and tags. Is this SQL set of queries equivalent to the latest connection queries, which is for both startups and startups _ tags, and we know that it's going to be this query because we removed the previous queries from the list of connection queries over here. So we expect this is going to be true, right? So those two are absolutely equivalent.